Good evening, everyone. And like yesterday, today there is also a small topic which we need to get out as soon as possible. This is known as polarization. It's a topic of JEE Main, and it has been added to JEE Advanced as well. So that is why we need to do it. It's a very small topic. It only has 2 or 3 formulae. If you understand those, we are good to go. We can expect a question from this, and that is the reason why we are doing this. So let us go and understand what do you mean by polarization. Have you heard the term polarization before? What do you mean by the term polarization? Anyone heard the term polarization? No one? No one has heard the term polarization. What do you mean by polarization? Or let us start with the term, what do you mean by normal light or unpolarized light? Unpolarized light. What do you mean by unpolarized light? Now you must know that light, when I talk about light, it's an electromagnetic wave. Have you heard about this EM wave? Light is an electromagnetic wave. So basically it consists of both electric field and magnetic field. We will get to know more about EM waves in the chapter on EM waves. Right now we are not concerned with EM wave. So basically it consists of electric field and magnetic field, and there is one direction of propagation. So these three are perpendicular to each other. The electric and the magnetic field are perpendicular to each other, and it is also perpendicular to the direction of propagation. So if one is along x-axis, the other one will be along y-axis, and the third one would be along z-axis. But when we talk about polarization of light, though it consists of both electric and magnetic field, we must understand that the magnitude of magnetic field is very, very small. Magnetic field का magnitude B is very, very small compared to the electric field E. Here we are talking about the magnitude. It consists of both electric and magnetic field, but magnetic field is very small compared to electric field. So normally when we talk about polarized or unpolarized light, we're talking in terms of electric field. That is what you need to understand. So now, even though light is an electromagnetic wave, we are going to take it as a wave which has electric field only. Magnetic field we are just ignoring. Now, when light propagates, there is a direction of propagation of light, and this electric field, in fact, this magnetic field is perpendicular to electric field is perpendicular to the direction of propagation of light. Both of all three are perpendicular to each other. But right now what we are going to do is we are going to neglect this magnetic field because it is very small. So what we have wish to say here is this electric field is perpendicular to the direction of propagation. Now if I imagine that the light wave is propagating along x-axis, and I will show you with the help of a diagram that might make you understand it better. I hope everyone has written this. Yes or no? So I will try to make you understand with the help of a diagram. You may draw this diagram, you may not draw this diagram. It is not very important, but the importance is that to understand it. So if I say that light is propagating along x-axis, and this is your x-axis for that matter, the magnetic field, magnetic field we are only neglecting. The electric field can be anywhere in the YZ plane. You can see this plane is the YZ plane. Do we understand this? It is perpendicular to x-axis. Electric field has to be perpendicular to x-axis, so it can be anywhere on the YZ plane. It is just like this. If light is propagating like this is the YZ plane. Electric field can be anywhere on this YZ plane. So these are the random directions of electric field vector. It could be anywhere. It could be anywhere on this YZ plane. This is how we describe it. If I look from the front, if I look at the front, if this is the YZ plane, electric field may be anywhere on the YZ plane. Such type of light, which has electric field oscillations in all directions, perpendicular to the direction of propagation of light, is known as unpolarized light. What do you mean by unpolarized light? This is the unpolarized light. Light having electric field oscillations in all direction in a plane which is perpendicular, in a plane perpendicular to the direction of propagation of light. This type of light is known as your unpolarized light. This type of light is known as unpolarized light. Do we understand this? Yes or no?
Yes, sir.
Note it down. You may not have to draw the diagram. Just have to understand what is happening. You may, if you want to draw a diagram, you may just draw this diagram just to make you understand that light is moving in all directions. Electric field is moving in all directions. Have you noted it down? Shall we move ahead?
Yes, sir.
Okay. Now, in the YZ plane, light is moving in all possible directions. So in the YZ plane, you can resolve it along the vertical, if you call vertical as Y, along the vertical, and Z along the horizontal, or no matter how you understand it, you can resolve electric field along these two directions. Now, all the three directions are actually shown here. And I just want to show you how all the three directions are shown here. This is X, the direction of light wave. Do we understand this? This is the direction of propagation of light. This is your Y-axis. And this dot actually represents your Z-axis. Do we understand this, bacha? So all the three directions are shown here. Electric field, light is moving along X-axis. We have resolved the electric field along the Y-axis and along the Z-axis. I hope you understand this. Dot represents Z-axis. I'll give you 2 minutes to understand this. Note this down.
Done, sir.
Okay, let's wait for everyone. But this is democracy. We have to wait for everyone. We live in a democratic world. Yes or no? Let us all be on the same page, and then I will move ahead. Let me know once you are done, bacha. See, it's a very small topic. You have to understand each and everything very carefully because of one of those things, beta, can come in the exam. Very simple
Completed, sir.
for you to come in the exam. So take your time and
Completed, sir.
then we will move ahead. Okay, completed? Yes, we'll move ahead. This is unpolarized light. Then what would be a polarized light? This was unpolarized light. What would be polarized light, or we call it plain polarized light? So, right, the next heading, polarized light. Now, if you apply some common sense, you should be able to find out what is a polarized light. Light having oscillations
In only one direction.
in only one direction. Yes. Light having oscillations in one plane, we call. Or in one direction, if you want to say. This type of light is known as a plane polarized light. So we must cancel all the other oscillations. If it is oscillating along y-axis and z-axis, we cancel all the oscillation along z-axis. We only have oscillation along y-axis. Or we cancel all the oscillation along y-axis. We have oscillation only along the z-axis. That becomes your plane polarized light. Do we understand this?
Yes, sir.
There are certain things that you must remember about this. So we'll write this. The plane in which oscillations occur your oscillations occur, that plane is known as the plane of oscillation. This entire chapter is based on these small things. Plane in which the oscillation occur is known as the plane of oscillation. The plane which is perpendicular to the plane of oscillation the plane which is perpendicular to the plane of oscillation, that is known as the plane of polarization. How is this polarization done? Light can be polarized by passing through certain crystals. These crystals, or you can call them polarides. I hope you have heard this term polarides. Yes or no? Polaroid camera, you might have heard.
Yes, sir.
The polarized light. So the next heading is, what do you mean by polarization or polarides? Everyone noted this down?
Yes, sir.
Polaroids is the next heading. Everyone noted this?
Yes, sir.
Polaroid is the next heading. What are polarides? So basically they are devices to produce what? Polarized light or plain polarized light. These are devices that can produce plain polarized or polarized light. They are based on the principle of absorption. So they will absorb light in one particular plane and they will allow light in the other particular plane. Okay. How do they function? So if I just show you this diagram, this might make things clear. How do polarized function? So this is a diagram that might be able to help you out. This is a diagram that I'm showing it to you. This, on the left hand side of this, is a light which is unpolarized. As you can see, it has, this is the direction of propagation. This is your y-axis and this is your z-axis. You can see this dot, big dots, dots, dots. So this is an example of an unpolarized light. Light is propagating along x-axis and it has oscillation along y-axis as well as along z-axis. When you put a polaroid, in front of it, it will absorb all the oscillation along the z-axis. And what do you have on the other side? On the other side, we have a plain polarized light. Oh, it's already written. Why I'm writing it? We have a plain polarized light. As you can see, this is the direction of light, propagation of light. There is only oscillation along y-axis and the z-axis wala oscillation has been cancelled. Do we see this? The z-axis wala oscillation is cancelled. Do we understand this?
Yes, sir.
Now you can see these lines here and you can just write it. You can see these lines. These are basically, you can call it the transmission axis of the polaroid. So these lines are basically the transmission axis. A polaroid only allows light which is parallel to the transmission axis to pass through them. Polaroid allows light which is parallel to transmission axis. Do we understand this?
Yes, sir.
Great. So along the transmission axis, whatever the oscillations are, it will allow them to pass. Now, one important thing that you must understand, if the intensity of this light is I, the unpolarized light, the intensity is I, on the right hand side, the polarized light will have intensity of I by 2. So what the light passes through a polaroid, the intensity of the light is halved. Intensity of light is halved after the polarizer. When unpolarized light falls on the polaroid, on the right hand side, the plain polarized light that you get, the intensity is halved. Will you remember this? Now sometimes everyone has noted this down, or shall I give you more time?
Completed, sir.
Boys, you have completed?
Yes, sir.
Okay, now sometimes what we do is after this polarizer, we put another crystal or we put another Polaroid that is known as the analyzer, because it analyzes whether your light has been polarized or not. What do you mean by analyzer? There is no difference between an analyzer and the first one is known as a polarizer. There is no difference between an analyzer and a polarizer. Both are doing the same thing. The only thing is the first Polaroid is actually polarizing the light. If you draw this, if you see this diagram, on the left hand side, the extreme left, you have unpolarized light. But this is the only diagram that you have to understand. This is P. So this is the first polarizer. It polarizes. This is the first Polaroid. It polarizes the light. Therefore, it is known as polarizer. The second Polaroid analyzes whether the light has been polarized or not. So the second one is known as the analyzer. A, analyzer. The first Polaroid, which is falling in the path of light, unpolarized light, is known as polarizer. After this, what happens? Your ordinary light gets converted into polarized light, and then analyzer analyzes what is happening, whether the light has been polarized or not. If the transmission axis of the polarizer and the analyzer are parallel to each other, the whole of the polarized light will pass through it. That is the important point that you must understand. Here, as you can see, both the polarizer and the analyzer, the transmission axes are parallel to each other. So the entire polarized light is passing through it. If I talk in terms of intensity, and that is the question that is going to come, the intensity of light here is I. What is the intensity of light on the right hand side of the polarizer? Left hand side was I, so right hand side will become
I by 2, sir.
I will do.
I by 2. Now after analyzer,
I will do.
it will still remain I by 2. Do we understand this, bacha, in this case? Yes or no? Because the entire light is passing through. Here, when it passes through the polarizer, white becomes I by 2 because one vibration, one axis is already gone. Do we understand this? You can remember it in that way.
Yes, sir. Yes, sir.
Remember, these are the only things that are going to come in this topic. It's a very small topic, but that's the last thing. You just have to do one formula and we are done. To do it carefully. Note it down carefully. Give you time, don't worry. Note this down carefully because one question is going to come and that question is going to be pretty damn simple. Most of the students will leave this because they might not understand what is happening. I'll give you 2 minutes to do this. Let me know, bacha, once you're done. Remember, it's a very simple topic, simple things. At any time, you can revise it in 2 minutes. Boys, have you done this, bacha?
No, sir.
Okay, okay. Let me know once you're done, bacha.
Done, sir.
Okay. Now, what will happen if I place the analyzer perpendicular to the polarizer? Their transmission axis perpendicular, and I hope you can see this. In second case, again, on the left hand side, extreme left hand side, I have unpolarized light. Intensity, let me start with intensity I, here I by 2. On this side, it is nothing, 0. So if the transmission axis of the analyzer, and you can see, because I've seen questions where they have drawn this diagram and asked what will be the intensity on the other side. They've given a diagram and asked. So it's very simple. If it is perpendicular, the intensity on the other side after the analyzer is going to be 0. That is the point that you need to note. Transmission axis of the analyzer is perpendicular. Then on the right of the analyzer, you will get nothing. Then we will have the first of the two laws which we have to do, the Malus law and then the Brewster's law, and then we are done. Note it down.
Completed, sir.
Well done. What about the boys? Boys are more. They take more time also. Girls are less. They take less time. But I hope it's not about time. It's about understanding. Because just now they've added this topic. They can very well give a question on this.
Completed, sir.
Okay, just give me a minute. Okay. Now, we have seen the condition that what happens when the angle is 0. We have seen the condition when the angle between them is 90 degrees. When I say between them, I mean the polarizer and analyzer. I mean the angle between the transmission axis of the polarizer and analyzer. What happens if they are at a different angle, not 0 or 90? Comes the first of the laws that we have to understand, Malus law. Malus law. And the best way to understand this Malus law is by giving you this diagram. Again, this diagram, just have to understand the angle between the two polarizer and the analyzer. If you understand the angle, this becomes very simple. What does it say? So let us start again. Here I start with the unpolarized light I. After the polarizer, it becomes I naught. This I naught is nothing but I by 2. Do we understand this? Now I have this polarizer and analyzer. Their transmission axes are not parallel and they are not perpendicular. They have an angle theta between them. Do you see this angle theta between them?
Yes, sir.
The Malus law states that, let me call this intensity because I'm using I here. I should call this as I incident. I means I incident. So this becomes I by 2. So this becomes I by 2 is I naught. Malus law says that the intensity after the analyzer, which is I, the intensity after the analyzer I is I naught cos square theta. And that is it. That is what that you need to remember. The intensity, the law states that the polarized light transmitted through the analyzer varies as the square of the cosine of the angle between the analyzer and the polarizer. So if I again go from the very first thing, this is II. So this will be II by 2. Then I can write this intensity here as II by 2 cos square theta. Most of the questions on this, in this topic, 50% questions come from this and the 50% comes from the other law. So this is 50% of your topic. Do we understand this? Yes or no? No, yes.
Yes, sir.
This is 50% of your topic. Have you noted it down? Have you noted it down, bacha?
No, sir.
Okay. Let me know once you are done, beta, so that I can move ahead. One more thing, and then you can solve 1 or 2 questions, and we are done.
Yes, sir.
Done, everyone, bacha?
Yes, sir.
Okay. This was Malus law. Instead of going on to the question of Malus law, let us first do the other law as well, so that we can do both the questions, one question each of both the things. Okay. The next one is known as your Brewster's law. What is this Brewster's law? So write the heading Brewster's law. Two things we had to study here. Brewster's law. Now, basically, this Brewster law is giving us a way of getting polarized light. And how does this Brewster law helps us in getting polarized light? Again, it is simpler to understand it from a diagram rather than giving you the definition. See, there's no point learning the definition and not understanding it correctly. The more important aspect is you understand it and then you can make the definition on your own. Now, this is the diagram. Can anyone make me understand what is happening here? Okay, I will tell you, it may not be very clear. Now here what is happening is a light, which is obviously unpolarized, is falling on a transparent medium. Now we have seen reflection, we have seen refraction. But remember, there is never 100% reflection and there is never 100% refraction. There is always some percent reflection and some percent refraction. Do we understand this? Yes or no? So here what is happening is when a light is falling on a transparent medium, some part of it is reflected back. This green is the reflected back, and this blue is the light which is refracted. This blue is the light which is refracted. Now, if you change the angle of incidence, and as you can see, this is the angle of incidence. If you keep on changing the angle of incidence, the angle of reflection and the angle of refraction changes. Yes or no?
Yes, sir.
At a particular angle of incidence, which is known as the Brewster angle, what happens at a particular angle of incidence, the Brewster angle, what happens is the reflected light that you have is completely polarized. So if I call this angle as theta p, Brewster angle is written as theta p. At this angle theta p, the incident angle, when the angle of incidence is theta p, the reflected light is completely polarized, whereas the refracted light is always partly polarized. What more happens at this Brewster angle, that your reflected light is perpendicular to your refracted light. So Brewster angle is a very peculiar angle. Two things happen at the Brewster angle simultaneously. When the angle of incidence is the Brewster angle, your reflected light is completely polarized. And at the same time, the reflected light is perpendicular to the refracted light. So Brewster angle is that angle of incidence on a transparent medium for which the reflected light is completely plane polarized. And also the angle between the reflected and the refracted light is 90 degrees. From here we can derive a simple relation between them. Tan of this Brewster angle is equal to the refractive index mu of this transparent medium. How did we achieve this? Sin I by sin R is mu R by mu I, and your angle of incidence is theta p, so sine of theta p, and your angle of reflection is same. You can find it out. The value of R in terms of this, Bijka angle is 90. So sine of I divided by sine of R becomes the cos of I. Sine by cos is tan, and that is how you get tan. I hope you have understood what I have said. So these are the two things that you must remember. At Brewster's angle, the light which is reflected is completely polarized, and the light which is refracted is at an angle of 90 degrees. Do we understand this? Yes or no? I'll give you
Yes, sir.
2 minutes to draw the diagram. I'm not giving you a definition because definition I'm not here to make you understand, make you remember the definition. This is what we'll need to solve the question, and from here you can definitely make the definition. 1 minute you have. Have you noted it down? Can I give you a question?
Yes, sir.
Okay, here comes a question,
Yes, sir.
and I hope that you should be able to understand the language of this question and give me a suitable answer. Remember, the topic is very simple. The only thing that they are going to do is ask you question in different ways so that you get confused, nothing else. When light of a certain wavelength is incident on the plane surface at a glancing angle, so they have not given you incident angle, they've given you glancing angle. That is the only thing that you have to understand. The reflected light is found to be completely plane polarized. Find number one, the refractive index of the material. Number two, the angle of refraction. I'll give you 2 minutes. Think about it.
Right.
Got the answer, bacha? Well done if you got the answer so quickly. Both the answers? Both the answers you got, bacha? No. Okay. Not to worry. You will get the answer. If you understand the question,
Root 3, sir.
root 3, that is correct. Root 3 is the refractive index. Well done. But one more question is left. What is the angle of refraction? This is a revision of what we have done some 15, 20, 1 month back. I hope everyone is able to do this.
At 2, sir.
How much, bacha?
30 degrees.
30 degrees is the angle of refraction. That is absolutely correct. No questions asked, no answers, no reasons given. That is absolutely correct. 30 degrees is the angle of refraction. Well done. Anyone else got the answer? Yes or no? No or yes? I'll wait.
Doing, sir.
Doing, sir. Okay, sir. 2 minutes, sir. I'll give you 2 minutes, sir. Let's see if the girls can match the boys. Boys have done exceedingly well with this. Girls, it seems, are lagging behind. So I think I must step in. Shall I? Okay. I think we are stuck. So I must step in and tell you how it is done. The glancing angle is given. Now, what do you mean by this glancing angle? Don't get confused. If I just draw the surface, I hope you can see this. If this is the surface, this is the incident light. Instead of giving you this angle, my dear friends, they have just given you this angle. This angle is 30 degrees. So remember the term that they use, the term is glancing angle. Do we understand this?
Yes, sir.
So the angle of incidence is 30 degrees, and at this angle, your reflected light is plane polarized. That means it is the Brewster angle. Yes or no? So tan of this Brewster angle, tan of 30. No, tan of not 30. This is 30. I've written it wrongly. This is 60. So tan of this 60 has to be your mu. So tan of 60 is mu. That's it. You get the value of mu as root 3. Once you get the value of mu as root 3, you then don't have to even apply Snell's law to find out the angle of refraction. You can find out the angle of refraction without doing anything. This is 60, my dear friends. So this angle has to be 60. Both are same. Everyone understands this? This total angle is 90 degrees because it's the Brewster angle. So there you can get the angle of refraction by simple math. The angle of refraction would be 30 degrees. Do we understand this? Yes or no? No, yes.
Yes, sir.
This is how questions are framed in this type. I'll give you one more based on the what? Polarites. And let's see who gives me the answer. You only have 2 minutes because 2 minutes class ends. So you will get 1 minute to solve this. And I will get 1 minute to explain this. The question comes now. Two polarites are oriented with their planes perpendicular to the incident light. And the transmission axis making an angle of 30 degrees each other. What fraction of incident unpolarized light is transmitted? Oops. I hope you understand the language of this question. The only thing that you have to understand here in this question is the language of the question. If you understand the language correctly, you should be able to get the answer. You have two polarizers. The first one will be called as a polarizer. The second one would be known as the analyzer. They are inclined at an angle of 30 degrees. Some light is falling on the polarizer. What fraction of the light you get after this arrangement? You have 1 minute. Let's see if the girls can do a better job this time. No? If you want a hint, as I told you, this one diagram encompasses the everything of this particular thing, and the hint is here, right here, in front of your eyes. Ting, 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 ting. This is the hint, my dear friends. The intensity after the analyzer is I by 2.
Sir, show that question, sir.
So that question, sir, there is nothing in that question, sir. 30 degree ka angle, sir. Or nothing, sir. That is the problem, sir.
sir.
Yes, beta?
Sir.
Yes?
8/3.
3 by 8?
8/3.
Hey, how it can be more than 1? Yeah, it has to be 3 by 8, not 8 by 3. Do we understand this? Yes or no?
3/8.
3 out of 8, 3 by 8, that is correct. 3 by 8 is the answer. So what I have to find out here is intensity after the analyzer. A fraction, that is II by 2 cos square theta. So basically what I need to find out what fraction passes. That means I divided by II, half cos square theta, cos of 30, cos square, half cos of 30 is root 3 by 2 square, that is I by II, and that is 3 by 8. And that is the answer, my dear friends. You just remember one formula, two formulae, the Brewster angle and this revolutionary formula, you are done. You're done with polarization. And if this question comes from this part, all the diffraction part only has two formulas each. Out of these two formulae, you might, and probably if I include wave optics as well, out of these three formulae, you might get even two questions. So we have covered two questions at least in the 6 or 7 days in those classes that we have used, and they are very simple. So on that note, I will wind up today's class. I hope we are done with this. We are done with wave optics. We are done with the wave nature of light. In the next class, we'll move on to the other nature of light. And we move on to one of the simplest topics, modern physics. So we'll start with modern physics and we will continue with your thermo in your Sunday wala class. Okay, so that's how I will go. If you have any doubt in this topic, please ask. Any other doubt, you can put it on a Telegram group. If you want to put it from a book, you just tell me page number of the book, tell it, ask it there. Whenever I get time, I will try to put the answer in the group, or in that Sunday wala class in the last 5-10 minutes, I will tell you how to do this. Okay, done.
Yes, sir.
Take care. Have a nice day. Please go through this. Only 2 or 3 questions you have to do, and one 4 marks is there. Bye bye.